In example 2, we're going to graph the hyperbola that's centered at the origin. If you notice, we have negative x squared plus 4y squared minus 36 equals 0. We don't have just that x term or just that y term, which means there's no completing the square that we need to do. So again, as we start getting things on the sides we want, we'll end up seeing that our h and our k are just going to be 0 and 0. So in order to get this situated the right way, I want to move my 36 over to the right, so I'm going to add that over there. And then I want my first coefficient to be positive, so I'm actually going to switch these two, the x squared and my y squared, around. So it's going to look like this. I'm going to get 4y squared minus x squared, and then adding that 36 over the other side is equal to 36. Now my difference between my hyperbola and my ellipse is the sign that's in between here. So my ellipse had a plus sign between my x squareds and my y squareds, and my hyperbola will always have a subtraction sign between them. Both, however, are set equal to 1. So in order to get this side 1, I'm going to divide both sides by 36. So I'm going to divide this side by 36, and that means I have to divide everything over here by 36 as well. And after I do that and I simplify, 4 divided by 36 is going to end up being y squared over 9 minus x squared over 36, and that's equal to 1. So now that I have it in standard form, I can go ahead and graph. In order to graph, I need to know what my center is. So my center is my h and my k, and since we don't have anything here, it's going to be 0, 0. And then I need to know my a and my b values. My a value is always first in my ellipses, or in my hyperbolas. So my a value is going to be 3, and my b value is coming from here, the square root of it, which is going to be 6. So I know a is equal to 3, and, sorry, that's a 3, and b is equal to 6. Now I need to look at my transverse axis and my conjugate axis. So I'm going to scroll up real quick to look at our formulas. We have the y squared first this time. So since our y is first, we are looking here where our parabolas or our hyperbolas are going to open up and open down. My transverse axis is my vertical, and my conjugate this time is my horizontal, both a length of 2a and then 2b. So looking at my transverse axis, I know my transverse axis has to be my vertical in this case. And it's a length of 2 times a, which would be 6. And my conjugate axis is going to be horizontal this time, and it's a length of 2 times b, or in this case, it's going to be a length of 12. So by hand, if I'm going to graph this, I'm going to start by plotting my center at 0, 0. And then I'm going to do my axes. So my transverse axis is a length of 6, and it's vertical. So I'm going 3 up and 3 down to plot those points. So my first one's here and over here. And then I'm going to do my conjugate axis, which is horizontal. It's a length of 12, so I'm going 6 in either direction. So I have 1 point here and 1 point here. And then I'm going to make my dotted box, my rectangle, that connect these axes or vertices. And then remember, my asymptotes are going to go directly through the middle and the corners of my rectangle. And then since it's opening up and down, I can get my graph on there. So my graph is going to open up and follow along those asymptotes, and it will open down and follow along there. If you have any questions, please let me know.